and I start by assigning a new section in our code, which we'll call biograph, and I clear the window here before we do this. If I want to have that each time, how do we go about? When we have a certain matrix and it's called my matrix, we want to display there's two things that we need to do. It's important that you keep these two things apart. First thing to do is to create a biograph object. How do we do the biograph object? We just use biograph, the function biograph, but we tell it which matrix we want it to use, and you can see in the help that pops up here automatically. We need to say which matrix to use and to interpret as a network. So ours was called my matrix. So I say biograph of my matrix will be our biograph object, but to assign it to an actual object in the workspace, I can, for example, call it graph. So this will produce a biograph object and assign it to a variable called graph in the workspace. The next thing, of course, we want to see this object, the visualization, and I say visualization of the matrix. We can do that by using the view functionality, and view needs to be applied to a biograph object, and we have only one defined, which is called graph, so I apply view. View, this will help us to bring up a graphical user interface, a display of the network. In order to later be able to manipulate the display and to change shapes, colors, and arrangement, we need to be able to have access to it. So we create an object from here as well. For example, calling it age, our handle. That will be our handle to this visualization of the biograph object, and we'll be able to access it later. So I have created the biograph object, and I have asked view to visualize it. So if I execute these 2 lines of code, I get some results already. To show us what we have, I make our graph a little bigger, closer, and you can see there's a couple of problems here. You can see there's something there. There's probably some boxes that might have to do something with the nodes, and there's arrows between them. But of course, the text that's written in there is so small that we can hardly see it. So for this, let's learn a couple of features that help us to manipulate this view in a way that helps us improve our display, which is something you need for your assignment. For this, we use the set command, and set refers to the visualized object, which is called age. So that's our handle, and with a dot we then refer to what is it that we want to manipulate. So the first thing in our case maybe has something to do with the nodes. So we say age.node, so that refers to all the nodes in our network. And what do we want? Well, definitely we want this font size to be larger. So if we then put into quotes font size, this is our first argument, and separated by a comma, we can then assign a font size, say 18 points. And if we execute it, you can see already gets a little larger. If you think that is still not large enough, maybe 2 is not, make it 22, and getting it bigger and bigger. For example, will be a display that is maybe more properly seen. And of course, it's up to you what you choose here. So you can see set is the functionality that we use to manipulate, in this case, all nodes. What shall we take as a next thing? Line color, maybe. Maybe color nodes. Maybe change the color of a node. If we have a special node in our network and that we want to highlight, so what we can do is we can modify its color alone. Again, we use set, and we know from before that this is set h.nodes, referring to, now this would refer to all nodes. How do we define a specific node? By giving it a number. So if we say number 1, then the node number 1, and you see which one that is if you look at the names of the nodes, node number 1 can be assigned a different color. Again, in quotes, we use the American way of calling color argument. And now we remember color in this case, and here's the only case we have to know RGB code. So that's why we had it before already. If we want to have that node, for example, all green, then we can say 010. And we just execute these two commands together. We get the first node in green. So that's a way of selecting certain nodes and giving them a different color. For example, if you have your soil biota, you might have different hierarchies, have the color differently. How would you color two nodes in a different fashion? Of course, you remember that convention. If you use square brackets, you can color the first and the fifth node differently. And if we execute it, we have indeed the first and the fifth node colored differently. What else is there to say? I might finish this before I hand over to Rob for the edges. Let me show you that the size or the form or the shape of the node can be also different, so that we can refer to the nodes, h.nodes, and change their shape in quote by calling the argument shape. Now we need to know what to call them, and you will have to look it up. If you download the code for this file, all the options that are available are given in the downloadable MATLAB file, and there's also a link to the MATLAB online help where you will find this supporting background argument, the supporting background information. So I just choose one. One of the options that we can do is ellipse. And if we choose that for all nodes, you can see all nodes will be turned into elliptic shape by choosing the shape ellipse. So there's ways of combining these things, and of course you can have only one layer of the hierarchy in an ellipse and another in a shape of a diamond if you would like to have it like this. Okay, I hand over to Rob for some further options.
So we can see how we can change the nodes. It's also possible to do similar things to the edges. So exactly as before, we use the set function. And now we use h.edges. And say we want to change them all, and we want to change the line color of all of the edges. Let's say blue, RGB blue. Okay, so I hope you can see all of the edges are now changed to blue. I don't know, is there a line width command? Can we make the lines wider? Shall we try?
Let me check.
Let's see if that works. Experimentation. Yeah, that seemed to work. So maybe a little bit over the top. So I hope you can see those lines more clearly now. Okay? That's great, but again we can do the same thing as before and change the color of an individual edge. So I don't necessarily know which corresponds to which edge at the moment, but let's just pick edge 5. And let's say now we would like that to be red. So RGB 100. Okay, so that line there, edge 5, corresponded to the edge between node 2 and node 5. So it's all nice. And so if you look up online, there'll be all the lists of all the things you can possibly change. And so doing it in code is really the best way to do it, because it means if you want to rerun the same code, rerun the same script, you end up with the same figure. However, sometimes if you really want to do the quick and messy version, it might be easier to do it by hand. So you can actually click and drag these things. So click and drag the node, we'll move it around the plot. I think we can do this. Can we do the same thing with the edges? No. The other thing we can do is right click on, say, a node and choose node properties. And this lets us directly access all the things we were accessing by code. So you can't see, it's probably too small, but color, font size, label, and line color. So if you click, the first one is color. So if we click on the little color selector, we can change the color of this. So let's make it pink. And it interactively changes to pink. We can do all sorts of things. We can make the line width around it bigger to make it bolder. We can change the shape to a parallelogram. We can change the text color to white, RGB all the way up to maximum. Okay, we can do all these interactive things. And all of these commands here correspond to things you can change by code. Again, if we close that, we can right-click on an edge and select edge properties. We can change the line width independently of the other lines, up to 10, say. Change the color interactively. Even add a label. I think, does this add directly to the... No. Okay, ignore that, sorry. All these things we can do interactively. Although, as I said before, it's best to do these via code if you really... unless you are really certain this is just a throwaway figure, because if you then run the code again, you get exactly the same figure as the output each time. Okay?
Okay. So there's a couple of more things that we can mention. Now you remember that if you click on a node, you find it encircled by red. It's a very thin red line, so you have to do it on your own graph to actually see it. And then you can drag this node to another direction. However, you will feel that the edges that sort of follow, but they might be quite messy. So to get rid of this, if you have your cursor on that window surface and right-click on it, and you will see there is an option to refresh the layout or to refresh the edges. So if you refresh the layout, it will actually redo the layout. So that's a terrible thing because it will take the nodes into different positions. But if you choose refresh edges, it will more or less leave the nodes relatively to each other as you selected them, but will try to make the edges a little bit more optimal visually. You don't have full control over this process because it uses partly random functionality. This is an optimization algorithm that has been developed by somebody else and that tries to sort of figure out what is the best thing to do. So you will have to experiment a little bit with it before you get your optimal edge distribution. Right. Now, a couple of important things. Once you have the graph that you actually want to show, it's probably not going to look as crazy as our network here. You want to have that printed or saved to your desktop as a figure. It doesn't work directly from the biograph viewer, but what you do is from the biograph viewer, you select under File, you get the option Print to Figure in the top left corner. And if you say Print to Figure, you will get a graphical user interface that is very much like the one that we've seen before, namely that we are used from when we do, for example, plot. And with this is no trouble at all. Again, under File, you can have Save As, and Save As will then allow you to pick from a number of different file formats. So if we take a figure file format like JPEG image or PNG, portable network graphics, you can save this. My matrix, stick it all the way to a figure, and it's then there as a figure file which you can include in Word document if you like to do so. So saving is also possible. And I think that sort of completes what we have to say about the biograph figures. We have shown you how to set up your network matrix such that you can control each node and each edge individually. You have seen how you can view the biograph and access all its individual options to manipulate its appearance. And finally, to save it as a figure or as a graph file on your desktop or computer or wherever you want to have it, to be able to put it into your assignment. Right. That was the third of our exercises. If I bring back our camera for the final part, we just want to highlight that once you are done with this, of course, there's many more things that you can do. We strongly recommend to practice biograph functionality. We have just given you a few hints, but if you look at the MATLAB online help for biograph or the bioinformatics toolbox in general, and you have the link in the downloadable MATLAB files, which is called biograph, so you can find the links there. Please take a look how to work with the help to find supporting information and how to manipulate, how to put in the arguments, what way the arguments expect the input to be. Remember, RGB color must be 3 numbers in a vector format. So that's things that you need to know before you're actually able to do it. If you have any trouble with this, and specifically also in the subsequent sections, which may be more on the mathematical side compared to this session, please post your questions and problems to a forum. Let us know what the trouble is, and we'll try to help you. If you have an error message, and typically that's where the problem starts, please not only post all the code that you have used, but also make a copy of this error message and put it to us, and we'll try to address, because then we can try to repeat first, see if we can reproduce the error, and then we can try to direct you to where to go and debug this code. Attempt the quizzes in order to get used a little bit to the graph theory, which we haven't done today, but which is useful to understand graph theoretic measures.